Greetings, Earthlings. I haven't made a video for a while about space-related subjects. I've been traveling around a little bit and kind of working on playing around with AI and seeing if I can get productive results. It's kind of a challenging thing. There's a lot of mistakes found in it, and one of the things that I came across was AI actually admitted that it had trouble with accurately responding when the question is related to things that humanity has never done before. Even if the core elements are structurally familiar to modern science and engineering, it kind of falls off a cliff. All that being said, I wanted to say a couple of things about lunar development that I think would be interesting to my YouTube audience. One is a lot of the material online talks about solar panels and nuclear power and maybe fuel cells, which are a kind of battery that uses hydrogen and oxygen to generate electricity. But there's another opportunity for making power on the surface of Luna, and when we tie all of these together, we really should have a distributed grid on Luna that allows us, that's our moon, Luna, that allows us to generate power in multiple ways and have one grid that distributes the electricity, just like we do here on Earth. Now, the means by which we could generate electricity on Luna that's a bit different than's been discussed anywhere else is actually very familiar to engineering technology today on Earth, which would be geothermal. The difference on Luna is that on Earth we have a hot side and a cold side for geothermal, and that's basically what you have to have in order to engineer a system where you have expansion and contraction, and that drives a turbine, and that turns a dynamo, and that gives you electricity. On Luna, we have cryogenic craters, and we have ice that we want to melt and extract the gases that come out of it, and we want to extract the water. The hot side can be the waste heat from nuclear power plants. It can be cooling for solar panels that are in the raw lunar daytime sun, and it can be heat from other industrial processes like working metal. What happens is you have a working fluid that contracts to dump its excess heat to melt water and allow the gases in that water to escape in an enclosure. You get the water, you get the gases. That's part of the benefit. The hot side, nuclear power primarily, has trouble getting rid of its heat because they're assuming you have to release it to vacuum, and that really isn't very effective. So you use the industrial process of extracting the water from the ice to get rid of your nuclear power heat. That gives you expansion and contraction, and that gives you rotation of your generator, just like a generator that you have in a car that charges your battery. Thank you very much. Have a fabulous day.